Continuing with completing the square, we have x plus 4, x plus 5 all over 4. So we can start back by having the equation 2x squared plus 5x plus 3 all over 2, 3 equals to 0. In this quadratic equation, we can say that for us to have a completing square, the step 1 will be I divide all the sides by a, so I'm going to have 2x squared all over 2 plus 5x all over 2 plus 3 all over 2 equals to 0. So I cancel this. I'm going to have x squared plus 5 all over 2x plus 3 all over 2 equals to 0. As we initially said up here, we had x squared plus we said that we had to prove x squared plus 5x all over 2 equals to x plus 5 over 2 all into squared minus this. So we will say that this part here, x squared plus 5 all over, if you want to try, you can do it. 5 over 2x, you are going to try it by yourself. I'm going to say that it's going to give you the same thing. This is going to be the same as x plus 5 all over 4 all into squared minus 5 all over 4 all into squared here. You do it by yourself and find that it's going to give this. So it's an expansion of that. So now I'm going to substitute it. Now to do the second step, which is step 2, the thing to have in mind is you take this value, you have x squared plus 5 all over 2x plus 3 all over 2 equals to 0. You just maintain the value of x and place it here, x. Plus, you take the same sign which is here and you put it here. The next thing to do in step 2 is you take the coefficient which is here, you divide it by 2. It's going to give you 5 all over 4. And then you put all this squared. Then in addition to that, you do a minus. Always put the minus outside the bracket when you've squared it. A minus, you take the same coefficient you found here, you put it 5 all over 4. Then you square that coefficient and you're going to have this value that I've given you. You can prove it and you're going to have the same thing here. So you have this, all plus 3 all over 2 is equals to 0. So you are going to have x plus 5 all over 4 all squared minus 5. 5 squared is 25 all over 4 squared is 16. The minus is outside, so it's not affected by the square. Plus 3 all over 2 is equals to 0. So x plus 5 all squared all over 2 all squared. So I can do the plus 3 here and to have the plus outside and do all over lowest common multiple of 16. Here I can have a plus outside and a minus on negative 2. So it gives me negative 25 here and plus 16 divided by 2, 8 times 3, 8 times 3, 24 equals to 0. So negative 25 and negative 24 gives negative 1, and negative 1 times a plus 1 here gives me a whole negative. So x plus 5 all over 2 all squared minus 1 all over 16. I can send it on the other side. Do not expand, because if you expand this, you're going to end up to have the initial equation we had. But we are trying to find the value of x here. So the next thing you have to do is to send it on the other side. So you're going to have x plus 5 all over 2 all squared is equals to 1 all over 16. Now I can find the square root of this. The square root will either be positive or negative. And the thing you have to have in your mind is that quadratic equation always have two roots. Always have two roots. That's why you have a plus and a minus here. Because if you have negative 1 all squared and you have plus 1 all squared, all of them are going to give you 1. So it implies that negative 1 can be squared to give you 1 and plus 1 can be squared to give you 1. That's why you see a plus and minus here, the square root of this. So if I square it, the plus and the negative are all going to give you 1 all over 16 as we initially have here. So I come back and I'm going to have x plus 5 all over 2 is equals to plus or minus the square root of up all over bottom like this. As seen in sets, the square root of 1 all over 16 as seen in sets is equal to the square root of 1 all over the square root of 16. The square root of 1 here is going to be 1. And the square root of 16 is going to be 4. So I'm going to have 1 all over 4. I put on the other side, x is equal to 1 over 1 negative plus or minus this and this. Continue by saying this 4. I have a plus or minus here, it gives me 1 minus, I put here 2 times 5, it gives me 10. Now I can have x be equals to high. Place here is 4, here is 4, here is 4, here is 4, and here is 4. So here is 4. So there's one error right up here. So when you continue here, you have negative 4 and you have 4 here. This 4 here is going to give you instead 5 when you divide. So you're going to have x is equals to plus or minus 1 minus 5 all over 4. Now x is equals to negative, you can have either, it's going to be either x equals to 1 minus 5 all over 4. 1 minus 5 gives me negative 1 minus 5 gives me negative 4 all over 4. Or x will be equal to negative 1 minus 5 all over 4. So this cancel gives me 1. So x equals to negative 1 here, or x is equals to negative 6 all over 4. I cancel here, it gives me 3. I cancel here, it gives me 2. So x will be either negative 1 or x will be equals to negative 3 all over 2. And if you find this, you'll see that it's the same answer we had when we were finding in the factorizing method. Now, we're going to pass to the last part, which is going to be quadratic formula. The quadratic formula states that if you have a certain equation ax squared plus bx plus c equals to 0, anytime you want to find for x, the formula is given as negative b plus or minus the square root of 4ac minus b squared all over 2a. So we are required to prove for this formula where you are going to substitute the value of b here, substitute the value of a here, substitute the value of c here. We can try with the same equation we had previously. So the same equation was 2x squared plus 5x plus 3 equals to 0. So my value of x will be, I take the b is positive 5, put negative 5 plus or minus the square root. The a here is 2, positive 2, so it's 4 into 2 times 3, the c. So 2 times 3 gives 6. 6 minus b squared is positive 5. So 5 squared, it gives me 25 all over 2 into a, which is 4. So 2 into 2, so x is equal to negative plus or minus the square root. 4 times this, it gives me b squared minus 4ac. So I'm going to have instead 25 minus 24 here. So 25 minus 25 gives me 1 year all over 2 into 2. So x is equals to negative 5 plus or minus the square root of 1 gives me 1 divided by 4. So x will be equals to negative 5 either plus 1 all over 4, or x will be equals to negative 5 negative 1 all over 4. This x is equals to negative 1 plus 1. Negative 5 plus 1 gives me negative 4 all over 4. Or x will be equals to negative 6 all over 4. Here cancels. X is equals to negative 1. Or here cancels. X is equals to negative 3 all over 2. So you see again that you have the same value as initially. Now, we are required now to prove for the formula x is equals to negative b plus or minus the square root of b squared minus 4ac all over 2a. So how do we prove it? The method for us to proceed in order to prove this is by completing the square. Now, how do you prove that? We start by saying that the step 1, you have this formula of quadratic equation. The step 1 of our completing the square is to divide all the sides by a. So I'm going to have ax squared plus bx all over a plus c all over a is going to be equal to 0. This will cancel. So I'm going to have x squared plus bx all over a plus c all over a is equal to 0. This is step 1 which has been performed. Step 2. We know that in step 2 we need to we have x squared plus bx all over a plus c all over a is equal to 0. For us to do step 2, we take this x, we maintain x here, we take the value of the addition, we maintain it here, plus, and then we take this coefficient of x here, we divide it by 2, b all over 2a, and we put all that into a square, we subtract it with this coefficient we've divided by 2, b all over 2a squared, and we add up with the last one is equals to 0. So it gives us x plus b all over 2a all into squared minus this gives b squared all over 4a squared plus c all over a is equals to 0. So now we're going to have x plus b all over 2a all into squared. We maintain a positive outside and we do a 4a squared being the lowest common multiple. We do it here, we're going to have negative b squared here, and when I divide here plus 4ac, you see already how the answer is coming up to us. So we have 0 here. We bring it on the other side, we're going to have x plus b all over 2a all into squared. When I bring it on the other side, this one was positive here, I maintain all here, so I'm going to change it to negative. It gives me negative into negative b squared plus 4ac all over 4a squared. So I have x plus b all over 2a all into squared is equals to, I multiply all the sides. So I'm going to have b squared minus 4ac all over 4a squared. Now I cancel and I do the same method. I know that negative 1 all squared and plus 1 all squared, all of them are going to give you plus 1. So it implies that for me to have plus 1, I can square a negative and positive. So the answer will be negative plus or minus. So I have x plus b all over 2a is equals to, I do the square root of, it gives me plus or minus the square root of b squared minus 4ac divided by this squared, it gives me 2a. So I'm going to have x equals to And when on the other side, give me negative b all over 2a plus or minus the square root of b squared minus 4ac all over 2a. So my final answer is, I'll bring it at the low and common multiple together. So it gives me negative b plus or minus the square root of b squared minus 4ac all over 2a. So here we have used the quadratic formula. We have proved for the quadratic formula. And this marks the end of quadratic equation solving. Thanks for your kind attention.